Hello students, scientists, and fellow polymaths. Welcome to our virtual classroom. Our class today will be based off of the following Texas Essential Knowledge and Skill Statements. We'll be learning about Earth and space, specifically how gravity is a force that governs the motion of our solar system. Yay, this lesson is about gravity. How exciting! Our objective today is you'll learn a lot about gravity, but you'll also be able to draw elliptical orbits just like the planets take. And you will be able to explain that gravity is a force that is determined by both the mass of objects as well as the distance between them. For today's class, you're going to need your gravity worksheet, and you'll be filling that out as you watch the videos. This will be the first of 3 videos. And we're going to get into very shortly a little history about astronomy and the theory of gravitation. So get your worksheet ready and enjoy the science.
For as long as people have been around, they have looked up to the skies and noticed how celestial bodies move in regular and predictable patterns. The sun rises each morning on the eastern horizon and sets each evening in the west. The moon goes through a series of phases from full moon to waning, to quarter to new moon, and waxing its way back to full moon again. We are all scientists in this class. What is the first step in the scientific method?
That's right, class. We make observations. The first step in the scientific method is to use our eyes, our ears, our nose, any of our senses to observe the world around us. Now, one strong evidence that humans have been observing the movement of planets, the sun, the moon, and all that comes in the form of calendars. We've had calendars across all cultures for a very, very long time. And the fact that we have them is evidence that even long ago, people were looking up to the sky and measuring and observing what was going on in the heavens.
The Wurdi-Yuang stone arrangement is thought by many researchers to be the oldest known surviving calendar. It is thought to be between 11,000 and 20,000 years old. It consists of over 100 stones and is nearly 50 feet in diameter. Some of the stones near the western point mark the positions of the setting sun at equinoxes and solstices, times when the sun is directly above the Earth's equator and farthest from the equator. Astronomy is the study of celestial objects, things we can see in the night sky. People who study astronomy are called astronomers. This is what the early astronomers who built the Wurdi-Yuang structure may have looked like. After making observations, what is the next step in the scientific method? That's right, after we make our observations, we start asking questions. Questions are the beginning of learning. Some of the most important questions we can ask are why and how. Observe this model depiction of our planets as they revolve around the sun. What are some questions you can think of? Record your best question on your gravity worksheet.
That's right. After we make our observations, we have to ask questions. Asking questions is the beginning of knowledge, and it's a key step in becoming a scientist and acting like a scientist. Now, I'm really excited to hear some of the questions you have. After watching that video, I had some questions of my own. Like, why is it that the Earth is going around the sun and not the other way around? Why are some planets seeming to move faster than other planets? Why don't the planets just fly off into space? And why don't planets crash into each other? And we ask these questions, and in order to determine the answers, we have to take the next step in the scientific method. So right now, tell me, what is the next step in the scientific method?
That's right, we make a hypothesis. A hypothesis is a potential explanation. It has to be based on our observation, and it has to be testable. Right now we're going to look at some of the hypotheses of gravity that we've had in the past. 2,400 years ago in ancient Greece, the philosopher Aristotle hypothesized that all motion had to have a cause. And therefore, some force had to be acting upon the moon, the sun, and the planets. Aristotle used the term gravitas, which meant heaviness, and that's where we get the term gravity. A few hundred years later, a fellow Greek by the name Aristarchus proposed the first recorded heliocentric view of the solar system. heliocentric view states the Earth revolves around the Sun, as opposed to the geocentric view, which states that the Sun revolves around the Earth. Around the middle of the 6th century in India, mathematician and astronomer Brahmagupta described gravity as an attractive force. He was building upon India's rich history of astronomy that held to a heliocentric model. Much of our modern understanding of astronomy comes from scientists, sometimes called polymaths, in the Middle East during the 11th century. Did you know this is where much of our modern math, including algebra, was invented? In 11th century Persia, modern-day Iran, Al-Biruni proposed that all heavenly bodies had mass, weight, and gravity. 100 years later, another Persian, Al-Khazini, suggested that gravity depended on the distance between objects, not just their size and mass. He was right. In 17th century Italy, Galileo de Vincenzo Bonaute de Galilei, or Galileo Galilei for short, became the father of modern-day observational astronomy. Galileo refined and built a telescope and used it to make detailed observations of the moon, stars, planets, and even supernovae, which are giant explosions of stars far, far away. With this data, he was able to conclusively conclude that the Sun was the center of the solar system. He did this by observing Venus and realizing it had the same phases that the Moon did. If the Moon phases were caused by the Moon revolving around the Earth, Venus's phases must be caused by it revolving around the Sun, between the Earth and the Sun. He also observed Jupiter's 4 largest moons revolving around it. In 1609, Johannes Kepler studied in detail the orbits of planets around the Sun. He was able to show that the orbits of planets were elliptical and not perfect circles. Planets did not move at a constant velocity, but sped up slightly as their orbits approached the Sun. The orbital period, or time it takes to make one complete orbit, was proportional to the cube of the distance a planet was from the Sun. This meant planets farther away from the Sun moved much slower than planets closer to the Sun. In 1687, Isaac Newton from England published his book, Philosophiae Naturalis Principia Mathematica. In it, he used Kepler's observations along with his own to develop his law of gravity. Newton's law of gravity says that any two objects exert a gravitational force on each other. This force is equal to the product of their two masses divided by the distance between them squared, and multiplied by a number, g, that Newton called the gravitational constant. This formula, in its simplicity, served as a usable model for predicting and explaining the motion of the planets and moons in our solar system for over 200 years.
All right, class, welcome back. Let's talk about some of the key takeaways I want you to get from this lesson. Now, don't worry about memorizing the formula. That's not for us to do right now. But the basic principles and how we got there are what's important. Most important is gravity is a force, and it's a force that governs the movement of all the bodies in our solar system and in the whole universe. Gravity depends on mass of the objects. All objects that have mass, that contain matter, exert a gravitational force. The bigger the size of the object, the more massive it is, the more of a gravitational force it exerts. That force of gravity is also dependent on the distance between two objects. The farther two objects are from each other, the less gravity will affect between them. And because both bodies exert a gravitational force, that causes the motion of them to be moving around in what we call ellipses. Now, before you move on to the next video, I want you to answer the first 3 questions on your gravity worksheet. In our next video, we'll be getting into some exciting experiments that you can do to explore the concept of gravity. For now, Goodbye, scientist. Professor Nick, signing off.